Hi everyone, my name is Fraser Cain and I am the publisher of Universe Today, and it's your chill, calm, relaxed, low-key virtual star party for June 10th, 2012. We've got no planets or the moon tonight, so it's all going to be deep sky objects tonight. We're going to have we've got two astronomers with their deep sky telescopes rolling. We've got Gary Gonella, who's down in Los Angeles. Gary, you've got a little bit of my window on the top of your picture there, just to warn you. So Gary Gonella is down in Los Angeles, and he's got his wonderful telescope, his Celestron with its fast. I always forget the name of this. What is it? The Fast
Star.
Fast Star?
Yeah, F-A-S-T-A-R.
Fast Star. Yeah.
Fast Star.
Yeah. So great big wide field of view, perfect for seeing really faint objects, really great sort of wide nebulae, things like that. And then we've also got Peter Lake, who lives in Australia but controls a telescope remotely in Arizona.
New Mexico.
New Mexico. Yeah. And so the view that we've got right now is actually the night sky around his observatory. And you can actually see the other domes around the horizon, and you can see the Milky Way coming up, and I can see the Big Dipper there. That's really cool. And the North Star.
I think it's the ISS that's just coming across.
Oh, is it really?
Domes there as well. You can see the streak.
And then we've got Stuart Forman, who was one of our astronomers, and normally we never see him, but tonight we get a chance to see him because he's I guess he has cloudy skies.
And I'm traveling in San Diego right now.
Oh, are you in San Diego right now? Oh, okay, cool. So we're just gonna, probably not a long one tonight. We're just gonna take a quick tour through a bunch of deep sky objects and try and give you some background information as we go. We're going to try something new as well, which is that we've got a really cool app that sits within our Hangout application that lets us see all the comments. So we can see all the comments that come in from live over on Google+. We can see them as they come from YouTube. We can see them as they come from Twitter, and sort of pull them all together into one location. So I can see that Howard has said hello, and I don't have to go and look at the actual Google+ page. So, hey, Howard, how's it going? You should be on the inside with us. But I know you've got Howard McCulsey was going to be joining us, but he's got high winds at the Canary Islands, which is where his telescope is, which was his scheduled time. So it would have been 3 deep sky telescopes working for the night, but we're just going to go with 2. All right, so let's get started then. So let's start with Gary. And Gary, you've got one of my favorite objects highlighted right now. So what are we looking at?
That is M57. It is the remnants of a star that exploded a long time ago. It's pretty small in the image, and in color, there's a lot of different colors in this area. But right now we're doing it in hydrogen alpha light, which lets me get these kind of pictures from light-polluted Southern California. I'll zoom out a little bit. This is the full view.
Yeah, so this is... That's the full view. Yeah, you've got such a wide field of view. I forget what it is. You've got how many degrees of view have you got in your?
A degree by a degree and a half.
A degree by a degree and a half, and the moon is about half a degree, right?
Right.
Yeah. So this is Gary's full field of view right now that you can see, and you can kind of imagine you could put say 3 moons sideways and 2 moons up and down to fill his whole view. So Gary has the ability to have these great big wide field of views. And so the object that he's focusing on right now is called the Ring Nebula. It's M57 in the constellation of Lyra. And M57 is a planetary nebula, and this is sort of the haunting future of what our sun is going to look like billions of years down the road. So what happens is our sun is a main sequence star, but as it reaches the end of its life, it turns into a red giant, and it will puff off its outer layers of its atmosphere out into space. And it does this sort of a bunch of consecutive times, each time puffing out these different outer layers of this atmosphere, and then it collapses down into a white dwarf. And so M57 is an example of one of these. But it's one of my favorite objects because it's the kind of object that you can really see its shape with almost any small telescope. Even, I used to have a little 4-inch telescope that I used to use, like my first telescope, and this was one of the first objects that I found my way to, and I would, if I was having people over and I was going to show them whatever planets were up, and then I would also show them M57. It's just a fantastic one, because even in the smallest telescope, you see this beautiful little ring. I really like it.
And in big diameter scopes, you can see the central star, which is really cool. And I can't see it in mine because I only have a 5-inch scope, but in Gary's you might be able to with visual observing, and certainly I've seen it with the big monster 20-inch Dobbs. It's a really neat view to see the central star.
All right, now.
Yeah. Oh, so Emerald One-on-One wants to know, is there a specific direction chosen for viewing tonight? We've got a list of about 15 objects I think we're going to try and look at. So this is just the first. Both Peter and Gary have a list of things, but they're going to be all over the sky, whatever we can get our hands on. Corey Wilder wants to know, he just saw Prometheus, so can we look at the LV-223 system, which I guess is the star system in Prometheus? I don't think we can. I don't think it exists. Yeah, so this is great. M57 is wonderful. Like I said, this is one of the best objects. It's a nice summer object. I feel like we're discussing wines. It goes really good with with chicken. But it's a really great summer object because it's in the constellation of Lyra, which is part of the summer triangle. And so if you really get to know you're out in the summer triangle is the most obvious. It's not a constellation, it's an asterism, right? It's three stars, the 3 bright stars in the sky in the summer. That's the summer triangle. And one of those is where the Ring Nebula is very unique.
Yeah, it's in Lyra, and it's actually really easy to find because if you look in that constellation, it's right exactly in between 2 of the stars in the constellation of Lyra, right by Vega, and it's really easy to find.
Yeah, and Gary and Peter have no idea what we're talking about here, but because they have these wonderful computer-powered telescopes that just take you, you punch in M57 and then it just shows up. But if you're guiding by eye, what's great about this one, right, is that you get this wide open. If you've got like a low-power eyepiece, and then you get a really wide field of view, and then you get those 2 stars in the view, and then you can put in a better eyepiece, and then you can sort of zoom your way in. But if the object is like out in the middle of nowhere, it's pretty hard by hand to manually guide yourself to the object. So yeah.
Especially in bad skies.
Yeah, it's just really, a lot of the cases when you're doing with binoculars or doing this kind of thing by hand, you learn how to jump from star to star, and you go, okay, it's just a little up and to the left of this star. Of course, with your telescope, everything is flipped upside down, and so you have to get used to kind of saying, oh, it's a little up and to the left, but it's actually down and to the right. And, yeah, it gets pretty complicated. So this one is really easy to find. Can you see it in binoculars? It must be sort of nice binoculars. No?
No, it's too small.
Too small, yeah.
Yeah.
So, but I used to find it all the time in a 4-inch telescope with I'm trying to think what kind of, even without the Barlow, with a 3 times Barlow, I was getting a pretty good view. I think I was getting about 100 power, and I was able to see it. So, cool. Well, so Peter, what have you got here? This is beautiful. Whoa.
Yeah, so that's M61. M61 is part of the Virgo cluster, and if I just zoom out a bit here, you'll actually see the whole of the cluster of a whole heap of galaxies here. You can see a couple of spirals there, a couple of edge-on galaxies, and it's part of the Virgo cluster, so this is one of the bigger ones in that cluster there. And we might just, a bit of trickery here, we might just move around and
sure.
Have a look at a couple of the others.
Now, what is the telescope that you're using, Peter?
So, because I'm doing this remotely, I'm not actually at the eyepiece. This is a 300-second image in the luminance filter, which I've just downloaded a couple of moments ago. And so I'm driving the telescope live and just presenting the images in my browser and sharing them through the Hangout. So you can see here there's a number of different galaxies all around this area, so it's quite a spectacular part of the sky.
But M61 is sort of the big the big fancy galaxy in this region. And actually, M61 has had a lot of supernova in it. There've actually been 6 supernovae discovered in this one galaxy. There was just one in 2008. And with supernova, astronomers are always on the search for supernova, because supernova, especially these ones called the Type 1a supernova, are used. Oh, that's a great view there. Are used as these cosmic yardsticks. So what happens is a Type 1a supernova will always explode with exactly the same amount of energy, because of the way they work. It's like, I believe it's like a white dwarf accreting matter from another star, and when it reaches the exact amount of mass, it detonates as a supernova. And so astronomers can know, because they know how much energy is coming out of it, then they know how far away the galaxy is. And they use this. This was the technique that they used to actually determine dark energy. So what astronomers did was they would take all of these. They would look out through space. They would catalog every one of these Type 1a supernovae that go off. And they have a very distinct energy signature. They would catalog all of these Type 1a supernova, and then they would be able to determine how fast these galaxies were all speeding away from us, from the Earth. And what they found, they were expecting that the galaxies would show that the acceleration of the universe was actually slowing down, but instead it actually turns out that the acceleration is actually speeding up. And this was this big, like, what's this about discovery? The exact opposite of what they were expecting to find. And this is what began this search for dark energy, which we now know is this sort of increasing acceleration of the universe that is going to eventually stretch the whole universe apart. So.
And of course, the big news of the week, Fraser, was the announcement of the Square Kilometre Array, the large radio telescope. So one of the low-frequency arrays has been awarded to the Australian site. So there was sort of a bid to host the Olympics style competition going on between Australia and New Zealand and South Africa, and I think the science community recognised that both sites had invested so much up front that it would, well, be a little unfair to go with only one of them. So they divided the science goals between the two sites, and the Australian site will have the very low frequency array that's going to go deep into the redshift and measure the oldest galaxies over the next 16 years or so. This project will be going on.
All right. Well, let's go back to Gary.
Okay.
And I see a cluster.
Yep, this is M13.
M13, nice.
10-second exposure of M13.
Only a 10-second exposure. So can you try a longer one?
You're not going to get much more out of it because we're looking at stars.
Okay, yeah. So M13, this is, and people always make fun of me, this is the globular cluster. Did I get that right? In Hercules. So I call them globular clusters. Oh. We've got some echo coming from Stuart. Yeah, so globular clusters are these massive collections of hundreds of thousands of stars that were all formed at the same time billions of years ago. And in many cases, these clusters were formed shortly after the actual formation of the universe itself. A lot of the stars within these clusters. In fact, for a while there, astronomers weren't even sure. Or they had a weird problem, which was that they were dating these stars, the clusters, to be older than the universe itself. Which, after a while, they figured out they figured out which numbers were right, and in the end, the globular clusters are younger than the universe itself. But still, they really are these relics, and they're the location that astronomers are searching for. So far, a sort of an unknown classification of objects called intermediate mass black holes. So we have the regular mass, the stellar mass black holes, the stuff where stars die, detonate as a supernova, and they turn into a black hole. And then we have these supermassive black holes, which are these gigantic, tens of millions of mass at the center of every galaxy. But it's thought that within these clusters, these globular clusters, you would end up with enough stellar collisions that you would get these intermediate black holes, maybe black holes with 100 times the mass of the sun. But so far, they haven't found many, if any at all, of these intermediate mass black holes. So M13, which is this great cluster in Hercules, is again another object that's really easy to find, and I would say even easier than the Ring Nebula, which was the other one that we looked at. Again, beautiful in the summer. It's a great thing to go and look for, and you can find it in a good pair of binoculars. And that's in the constellation of Hercules. And seriously, if you're serious about this, head outside, take a pair of binoculars, start to learn your constellations, and Hercules is going to be one of the first ones that you find. And when you do learn Hercules, you'll see he's got this sort of chest in, there's sort of a rectangle or a sort of trapezoid, which is his chest, and M13 is right down one of the sides of his chest. And
the other thing I recommend, Fraser, is to get a decent beginner star atlas to help you out. There's Terrence Dickinson or Dickerson.
Yeah, Night Watch.
Night Watch is an awesome book. It's an
absolutely,
awesome
totally
book.
agree. Yeah, everyone asks me, where do I start? I always say Night Watch.
Night Watch. It's a terrific book because it only gives you the good stuff. It leaves out all the extraneous stuff that you don't want to look at. Yeah. But Night Watch is a wonderful book, and I still use it, and I've been doing astronomy for 15 years. So.
Yeah, me too. In fact, I ruined one and went out and got another one, and I think the more recent one is even a little more bulletproof. So, yeah, it's absolutely the best book to go with. Good pair of binoculars and Night Watch will take you a long way in understanding space. Yeah. Well, that's fantastic. That's beautiful. So, I mean, can you give us a bit of a bigger view, Gary? Like even just like zoom it in a bit?
I can a little bit.
Yeah.
At this point, since I'm running the camera bend, we're reaching the point where we start getting the square stars.
Yeah. Or maybe they really are square stars.
Yeah, they are. Yeah, there's some of them out there. But yeah, I brought actually the Ring Nebula that I was doing was just at a 2x2 bin, and this is a 4x4. So I'm taking, in the 2x2, I'm taking 4 pixels of the camera and making them 1 pixel. In the 4x4, I'm taking 16, and that allows me to get a lot more light quickly. For the big sky objects, it works real good for this kind of thing.
Yeah. Yeah, that's, again, one of my favorite objects. You know, depending on the power of your telescope, you get this really kind of little fuzzy ball. But I mean, in yours, I mean, you can see all of these separate stars. I'd be interested to see what Peter can come up with on M13. What's Peter's got?
Yeah, so it's M58. That's
M58.
Large Spiral Galaxy.
Oh, that's beautiful.
Yeah, so I haven't. Should do a bit more homework here and tell you a bit more about it. But,
it's another spiral galaxy in the constellation of Virgo.
Yeah. So we're in Virgo part of the sky at the moment. So I don't know if this one has a common name. I'll just see.
And I see. So for the longest time, this was the most distant object that astronomers knew of. So
that's a beauty.
Adam Corbin wants to know, he'd love to get a telescope, but doesn't want a crummy one. Any suggestions on a good telescope at a reasonable price for an enthusiastic beginner? So,
I do.
Yeah.
I have one. Yeah. Any of the Dobsonians that are...
Oh, we lost him. I could finish that answer though. So a Dobsonian telescope are inexpensive and very powerful, but they're a little harder to use and track because they don't have any fancy mount. And so I'll see if I can dig up an image of a Dobsonian telescope while I go. But it's essentially, it's one of these telescopes where the I guess is my Dobsonian around? Anyway, the mount, the telescope comes down into a mount which is down on the bottom, and then it can kind of pivot around, and then the whole telescope is held by this mount down at the bottom. And so it's, you know, it doesn't have a tracking. There's no automatic tracking. There's no way to. It doesn't even sort of tilt at the plane of the ecliptic, so you can follow objects in the sky. It is just a raw. They call them a light bucket. That's a Dobsonian telescope, and so you can pick up a pretty powerful Dobsonian, a 6-inch for $300. But I mean, Adam, I would recommend, if you don't already have, I would start with a nice pair of binoculars. You can get like a 15 by 70 pair of binoculars from Celestron, like really astronomical binoculars. And there's something really special with that. Oh, we lost your image, Peter.
Yep, I'm getting it back.
Yeah, just go back to the screen share. Don't even bother using the, yeah. No, this is, oh yeah, okay, all right. So yeah, you want to go with the Dobsonian. That's sort of the one path to go. If you do want some tracking, if you do want some kind of, like a go-to, you know, any of the sort of the inexpensive ones from Celestron are just fine. You know, you can pick up a Celestron like I forget the numbers of them, but for about $400, $300, you get a pretty good telescope that's gonna track for you. You know, it's more important, if you do want to track, it's more important about the mount than it actually is about the optics and the actual aperture itself. You know.
Yeah.
I got dumped off. I don't know how much you heard, but I would recommend a Newtonian Dobsonian scope. I'm sure you talked about it already. But yeah. Okay.
Yeah. So right. So if you just want light gathering power, check out a Dobsonian. If you do want a tracking, which is pretty sweet. I mean, this is what Gary and Peter are doing right now. They're just like, you know, they're punching in the next object, and the telescope switches over to the new object. It's a pretty sweet way to go. So in that case, you know, I think, what is it? I forget the numbers. Celestron like a 110. I forget the numbers. Anyway, spend about $300 with Celestron. If it has go-to capability, you'll be happy. Rich Gillian says he's got 12 by 60 Celestron binoculars, and they're $60 at Amazon. So that's exactly it. You know, 12 by 60s are going to be nice, or even like
with that magnification though, you are going to probably need a tripod to look at it, because otherwise it gets real shaky.
Yeah, or a really comfortable chair.
Yeah, and I think for beginners, the key thing is not making the process too difficult. I mean, when I was a beginner, I used to, you know, if you're poking around the telescope trying to look for something and you're outside and your neck's getting stiff and cold, you know, they're the kind of things that you kind of put you off a little bit. So you've got to work through that little barrier, and having a mount that's easy to use and easy to point and easy to find things, as per that process Fraser was describing before, really star hopping your way onto some objects. The other thing that's really helpful for beginners is some of the iPad and smartphone applications you can get for sort of like star maps. They use the mechanics of the iPad to show you what's up in the sky, and then you can find the stars by name and zoom in that way. So that's quite helpful too.
Yeah, I have Skyfari on my iPad, and I really like it.
Yeah. Yeah, okay. Yeah, so Adam is saying Night Watch and a Dobsonian. So definitely Night Watch. If you have binoculars, that's great. So just remember, Dobsonian, you're going to get a lot of light gathering power, but it's going to be a bit of a pain to use.
If you have a Telrad though, which is sort of a bullseye way to look at things, this actually can be pretty easy, and you can move and look at things reasonably quickly if your skies are dark, and you can get some stars that you can look at in relation to the bullseye. But I loved my Telrad, and I used my Dobsonian with my Telrad for years.
I've actually been mucking around trying to hook up my laser pointer, my green laser, to my telescope, because I can see the beam right up into the sky. And if I can get it, I've been able to get it kind of quite closely aligned, and so I can take the telescope, move it around to point it at the object in the sky that I want to look at, tighten off the telescope, look in, turn off the laser pointer, and it's right there. So it's
wow, that's good.
That's another way to do it. Yeah.
That works well, and Orion has a mount specifically for that.
Or a laser for like you can clamp in a laser pointer, like a green laser.
Yep.
That's
Yep.
cool. Yeah.
Specifically for that.
So what have you got, Gary?
This is the Owl Nebula.
Oh, amazing.
And for the first time, all the time I've looked at this, I can see the owl. I see
Yeah.
the two eyes, and I see the nose.
Why do you think you're seeing it so well? Is it just really high in the sky?
Yeah, it's pretty high in the sky. It's and right down here we've got a galaxy also. Trying to figure out where
I
my
love that at the same
scope
time.
shot.
That's a great shot because
Yeah.
that's quite a small object in a deep sky. Even in the biggest telescopes, it's not
Yeah,
that
especially for Gary's scope, which is amazing.
So this is also known as M97, and this is another planetary nebula. So this is like the M57 that we saw earlier on. We got another example of of the future of our sun. So after a star has gone through the main sequence phase, turned into a red giant, puffed off its outer layers. But what's interesting, and this is the part that astronomers are still really puzzling over, is that it seems like every one of these planetary nebulae is different, that they create a different outcome. You can see different like, it all depends on like maybe the spinning of the object, how fast it was spinning, or the magnetic field, and so you get these really strange structures. And there's a lot of other ones. There's like the helix, and there's the Eskimo Nebula, and there's a lot of these, and each one has a really different structure. And so no two planetary nebulae are the same. So, oh, that's beautiful. Oh, Jayesh Kapoor recommended that I should put a link to the virtual star. Yes, I should. I keep forgetting, now that we've created the virtual star party, I always forget to start them up from the virtual star party, and so I'm going to do that right now. But that's fantastic. That's congratulations, Gary. This is because we've seen you take a crack at this before, and it hasn't looked this good.
Yeah, it's a very clear night, and it's high in the sky for me right now. So those are what we've got going for it. But yeah, that came out nice.
Great.
I like it.
Yeah. Yeah, fantastic.
So M63 is on my screen, Fraser.
Okay, we'll switch. Fantastic. So M63. So wow, it's just like nebula galaxy party here.
Yeah, that's. So I've got M91s next on my list.
Right. So this is
ready.
this is known as Sunflower Galaxy, Messier 63, and it's a spiral galaxy in the constellation Canis. How do you say this? Venatici? How do you guys say that?
Yeah, something like that. I'm not sure. The Sunflower Galaxy.
The Sunflower
and you can
Galaxy.
kind of see it does look like a sunflower.
Mm-hmm.
When you're driving along the road, you see those sunflowers sitting up, following the sun across the sky, and that's what they look like.
And yeah, no, that's beautiful. So, what is your telescope, Peter? What is this telescope? I know you're operating it remotely.
So yeah, this
through the
is
internet.
a 20-inch plane wave. It's a half-meter mirror, and it's what they call a corrected Dal-Kirkham. So it's got the boxed-in part around the mirror, like you'd have a Schmidt Cassegrain, and then it's got a truss out to the secondary mirror. And it's got a Finger Lakes PL11002M, which is a large, I think it's 12 megapixel camera or something. Yeah, it's 488 by 2675.
So it's about 4 inches bigger than Gary's telescope.
Yeah, and so certainly it can pull in a lot more light. There's, I think it's a non-linear sort of relationship between the aperture. So sort of, I think, for for every 4, Gary might know more about this, but every 4 inches you go, you double the light collecting power, I think, from memory.
Yeah, something like that. 20 inches is a lot more square surfaces than square surface than 14.
And then do you own the telescope, or do you rent it, like share it with other people?
Yeah, so I use it for about 10 to 15 hours a month myself, and it gets about another 50 to 60 hours of science use, and other people taking photos on it as well. So we rent it out.
Yeah, and this is actually like a scientific telescope, which is really great.
Yep. And
what are you finding is Gary? Now someone asked. So MI Army guy asked for if there's any colliding galaxies viewable.
That's a good question.
Think of one.
M51.
M51. Yeah. If someone can try getting M51.
Yeah, I've got that next on my list. Right now I'm doing, there we go, did the 60-second. Let me get the lighting about right. This is NGC 4406. It's called Markarian's Chain. So there's a whole bunch of galaxies in this photo.
No, I'm still focused on the wrong one. Here, hold on. There we go.
Okay. Yeah, NGC 4406, and all of these are galaxies. Let me see if I can brighten it up just a touch. A little bit more here and give it a little more.
No, go the other way.
Yeah, I'm trying to hit the
Gary, what's your camera?
The QSI 583.
Okay.
Yeah, I'm just getting some galaxy images there. Yeah, I think I see like 1, 2, 3, 4, 5, 6, 7, 8 galaxies in there.
2 up here. There's one here. There's one here. There's one here. There's one here. This is one right here. This is one here, and I would be willing to bet there's another 10 somewhere in that picture.
Yeah.
Yeah. Where there's one, there's often more.
Yeah, only a few billion. We're going to run out of them. But I always thought that's a nice thing to look at. It also, long exposure and taking it in color, it gets a real nice view. I think I'm all the way, I'm all the way zoomed out.
Gary, are you going to upgrade? Are you going to upgrade yours to the 683 now that it's out?
You know what? Actually, I've got it on order, and I was going to upgrade, and he called me and said, "I want to talk you out of the upgrade." He says the 583s are selling so well on Astromart. Buy the new one and sell yours, and it'll be cheaper. So that way I won't be without a scope. I was concerned because I'd have to camera. I'd have to send it back to him to get the upgrade.
Right.
So are you going to sell your 583 on Astromart and then buy the 683?
Yep. When I get the 683, then I'll sell the 583.
Yeah, because I'm seeing them being unloaded on Astromart. Every few days I see a new one pop up.
Yeah, and I guess they're still holding their price pretty good. So, but the biggest thing is that 1 second download during focusing. That's my biggest complaint with the camera is on full resolution, it's about 40 seconds to download a full image.
Yeah, it's exactly the same chip, the 583, the 683. It's just that they've upgraded, as Gary said, the download speeds between each frame.
And the cooler couldn't handle 5 degrees C more.
Oh, because you've got such warm weather there?
Yeah. Right now it's it's pretty cool. It's 63 degrees out. It's I've got the camera set at minus 15 degrees C, and I'm reading the outside temperature at 28.6 C. But I think that's reading a little high because it's in by the electronics. 82. Yeah, that's reading high.
Yeah.
63 Fahrenheit out there, and I'm running at minus 15 Celsius. Okay, looks like Peter's got something, and I'll move on to M51.
Yeah, that'd be great. So, okay. So, MI Army guy, you wanted to see a colliding galaxy, so we will show you one. Um,
don't know if it's colliding. There's certainly edge on and a very
Something.
unusual shaped one. Yeah, it's M98.
M98, okay, great. Let me dig that one up.
Let's see if I can zoom in a little bit more without stretching the quality too much.
Right, so this is a spiral galaxy in the constellation of Coma Berenices. And again, since it's one of the Messier objects, right, it's one of the objects that Charles Messier identified in his famous catalog as a way to stop being confused when he was searching for comets. So Messier was actually a very prolific comet finder, and so what he did was he was constantly he would see these blurry objects in the sky and go, oh, is this a comet? Is that a comet? And so what he ended up doing was he just sat down and he cataloged every single object that he had seen that kind of was comet-like. And so we now know them as a collection of either galaxies, nebulae, or clusters. But because in his case, with his telescope, he really couldn't tell the difference between them. I wonder what kind of a telescope he would have. I wonder how it would compare. You know, I'm sure Gary's telescope is probably more powerful than the one that Messier used.
Well, the biggest problem in that time frame is they didn't have mirrors. They had metal called speculum, and it constantly had to be repolished. It would tarnish and have to polish it, and it tarnish and have to polish it. So
yeah, and they of course didn't have a CCD, which is the thing that revolutionized astronomy, right?
yes, yes.
So yeah. Okay, great. So let's go back to. One thing as well is interesting is this galaxy, this one that Peter has here. This is M98. This is is one of the members of the Virgo cluster, which is sort of a nearby cluster of galaxies that we're sort of entangled with gravitationally. But yeah, so can you get a little bigger on this, Gary, so we can see that M51?
That's the 10-second exposure.
Oh, you're going to do a longer one? Okay.
It's doing a 60 right now.
Right. So someone wanted to see a colliding galaxy, and so this is known as the Whirlpool Galaxy, and so what you can see is that it's this face-on galaxy with these beautiful spiral arms. It's one of the, right now Gary's doing a longer exposure on it. So right now it's a fairly rough image, but you can see it's got these beautiful little spiral arms. We're seeing it face on, and so we're looking right into it. But then it's got this other object on the left-hand side of it, and this is known as M51b, also known as NGC 5195, and so astronomers aren't exactly sure whether it's a companion to the galaxy or sort of what is really going on. But now they really think that it is a companion. So what's happening is that companion galaxy is actually sort of tearing off a chunk of the stars, creating this tidal tail that's stretching out to this second galaxy. And that's what happens. A lot of the galaxies, in the far future, we're going to be colliding with the galaxy Andromeda. And there's a great story that was just done just a couple of weeks ago where they did a simulation of what Andromeda is going to look like in the far future, billions of years from now, when it's just huge and in the sky. And eventually, the Milky Way and Andromeda are just going to collide as two galaxies. The structure of both galaxies is going to come apart, and the two galaxies will sort of just smear together and eventually turn into this irregular, globular galaxy. But don't worry, because what will happen is that space is really big, and so it's not like any of these stars are actually going to bonk into each other. So you can imagine like two clouds of bees going past each other, and the stars will just pass right past each other, and then they'll pass past each other again. So at no point are the stars actually going to be smashing into each other. But the galaxy structure itself will be totally destroyed. So
the gravitational interaction will, tear everything apart.
Yeah, yeah, and a lot of the sort of old, and what they'll also do is they'll force a lot of the unused gas in the galaxy into sort of rapid star formation, but then all of the star formation capability of this new super galaxy, which we haven't figured out what we're going to call it, Milkomedia, will get used up, and then the stars will age, and so the galaxy will turn like a redder in color, because it doesn't have that blue hot star formation anymore.
And I don't think it'll be a problem for us, is what we're going to call it. It's several billion years away.
No. Yeah, the sun will have died before we collide with Andromeda. So I wouldn't be that worried about it.
Yeah, don't go dig a bomb shelter right now.
Don't panic. Don't panic.
Big friendly letters on the cover.
So Wendy Cahoon wants to know, can you explain the heating of Gary's telescope? What is causing the heat? The heat is his baking in the Los Angeles sun. So what's the heating and what's with the cooling, Gary?
Okay, this is I just popped the picture of the scope up, and my camera is up in the front part right here. The light comes through here, hits the main mirror down here, and then reflects up to the camera. Normally, if I was using this for visual, I would have a secondary mirror here, and then the eyepiece would be down here at the bottom of the scope, and that would make it what's called an f11. With my camera sitting at the front, it's actually f1.9. And what the heating is, CCD chip that's actually taking the image produces noise. There's always some noise in the chip, but the noise reduces as you take the temperature down. So just the chip itself has an electronic cooler on it, and I can take it down to minus 25 or minus 30 C. But by minus 15 to minus 20, you don't see much difference going colder than that. But by cooling the chip down, you get less noise. Noise is something that will always be there. There's a fixed noise, and then there's random noise. But especially the random noise will go way down as it's cooled.
There are ways to cool a digital single lens reflex as well. You can do it internally. It's called with a Peltier cooler that runs directly in the camera, or you can get actually a box that goes around the whole camera that physically cools the whole thing. So you can get some cooling with the digital SLR, but you're going to get better cooling and lesser noise with a camera like what Gary or Peter have.
Yeah. And one thing to keep in mind is mine is not a color camera. If you do an SLR, you'll get a color picture. Mine is a monochrome camera, and I've got a filter wheel in front of it that I switch in different filters. Right now, I've got what's called a hydrogen alpha filter, which is very, very narrow band. I live in the Los Angeles basin, and there's not much sky up there. If I try to look at it at all the light levels, I just see a bright sky. At the hydrogen alpha, hydrogen is the most common thing in the universe, and when it gets excited, electron moves up to a state, and then when it drops, it emits a photon of light. And a photon of light is at a very specific color. It's a red color. So I have a filter that's extremely narrow that just lets that light through, but you still see a black and white image because I don't have the other colors.
There are blocking filters that you can get for single lens reflexes as well that will block out ambient light. I have one that made by Astronomic that actually clipped right into the camera itself that decreases the amount of ambient light. So that can help you.
Yeah, I've got the same filter, and it does a nice job.
So, am I Army guy? I hope that solved your need for colliding galaxies. Let's move over to what Peter's got. And I got a couple of questions. So Corey Wilder said, just be wary with going with a big daub. He has a 12-inch, which is great, but it stays at the office, and you don't use it as much as you should.
Right. A telescope doesn't help you if you never take it out.
It's the same thing that you say with cameras, right? What's the best camera to get? The best camera to use is the one that you'll carry with you. I was out for a walk in the forest today, and I happened to have my iPhone on me, and I took a bunch of really nice pictures, all from my iPhone, because that's what I had, and I was able to get the pictures and You know, I didn't have my DSLR with me, so it's always great to be, you know, same thing with your telescope. If you've got what Gary and Peter have, you know, with a nice comfy setup, a way you can sit in your home office and control your telescope, then that's perfect. But if you need to like carry it outside like Stuart does, then the weight and setup time and all that is definitely a consideration. So
when I had my 8-inch Dob, though, 8 inches is a really nice weight. It's very light. Anybody can carry it out. I could set it up in 10 minutes, and it's a reasonable size for, especially if you live in the city. If you get anything bigger than 8 inches, if you live in the city, you're just going to get sky glow anyway. So I found that 8 inches was a really nice happy medium, and it set up really quickly.
Yeah, and one of those like Schmidt Cassegrains, the short telescopes, they set up pretty fast. So I think that's a good way to go, and they've got a nice tracking. I mean, spending about $1,000, I'd say, is sort of the sweet spot. You know, then you can get like an 8-inch Schmidt Cassegrain with a reasonably good go-to mount. That's when you sort of get. And if you've already got a DSLR camera, then you're set to do really nice astrophotography work. Now, none of our DSLR people are here tonight, but usually we've got a couple of people that are using a DSLR.
I am.
Stuart usually does. Yeah, and it's beautiful. It's a wonderful sensor built in. You've already got one,
right. So
bolt it onto your telescope and be able to take some just gorgeous photographs.
Yeah, and you can do it unguided if you have reasonable polar alignment. If you do shots not longer than about 60 seconds, if you go longer than 60 seconds, you start seeing star trails, and you're gonna want to start doing auto guiding. But if people are interested, there are some really nice beginning tutorials that I can point people to. One is called, I think it's called Starizona, Starizona, that has some very nice beginning astrophotography tutorials.
Yeah.
Yeah, Dean's got some great stuff there.
Yeah. So Vance McCauley wanted to know, Gary, what fast star camera are you using?
Say that again?
What fast star camera have you got going?
Fast star camera.
Yeah. What's the camera you've got?
The camera is a QSI.
QSI.
It's a 583.
Yeah.
And it's made specifically for this. It's also used in scientific and that kind of stuff, but it's designed specifically for this. In fact, what I can do is once we do the shots, I can bring the scope down and they can see it in the front of the camera, in the front of the scope. So
Peter, is that you posing with the telescope?
Yeah, that's one that won't fit in the back of a sedan.
Yeah.
So that's my scope. Yeah, it's fairly, and yeah. So I think for beginners, it's about what you can take with you. And as soon as you get to 12 inches of dolly, you're getting up around 30 kilos, which is a bit cumbersome. And you know, you'd probably take that on a camping trip to a star party, but you wouldn't drag it out necessarily for 5 minutes, you know.
Yeah, and I mean, sky, you know, nice dark skies are such a treat. You really, you know, if you can carry a nice portable telescope and you go camping with your friends and you can bring out the telescope and give people a view of the sky that they just never would get a chance to. So portability is really key. If you happen to live in a really dark place, then by all means. But for most people, day to day, I mean, you're going to see the moon, you're going to see the planets, you're going to see some of the brighter deep sky objects, but not a lot. Almost any telescope will do that. So you don't need, you know, it's when you know you're going to get access to deep skies, you know you're going to try and do some astrophotography, that's when you need to really start spending. But just a couple $100 to get a starting telescope. Just pick one of the, you know, reputable manufacturers. You can't go wrong with a Celestron. Can't go wrong with a
Meade,
Vixen,
even Orion.
An Orion, yeah. Especially their Dobsonians, but yeah. So any of those ones, you just want to avoid the department store ones. You know, you should not be buying a telescope from Walmart. You do not buy a telescope from Target or Canadian Tire in Canada. Like, you just avoid those guys.
You're wasting your money. You're throwing it away.
You're totally throwing your money away. Yeah. So, well, let's. I think we're starting to run out of time. So why don't we just look at a couple more objects and then we'll wrap it up. So now, Peter, you had something, but you didn't tell us what it was. It looked beautiful. Can you go back to that thing? and I'll see what Gary's got.
Yeah, I think that was M90. No, we've done M98. I think it was M91.
And Gary, what have you got? This looks like another globular cluster.
M5 with
M5.
a satellite.
With a satellite? Look at that, yeah.
Yeah.
That's fantastic.
So, and it's a 10-second exposure, and I got a satellite going through the picture. That's part of what we deal with, a lot of satellites in the early evening and airplanes. The reason I know it's a satellite and not an airplane is because it's a nice even line. If it was an airplane, I'd get the blinking lights, so we would get brighter and as it goes across.
That's great.
In 10 seconds, that satellite went that distance, right across the picture.
I just got a Twitter message just a second ago that I've got 4 passes of the International Space Station going over my house tonight. So if you're using Twitter, which I mean obviously you're using Google Plus, so why would you use Twitter? But if you do use Twitter, you want to sign up for a service called Twist, TWISST, and what it does is they figure out where you're located from your address in Twitter, and they'll send you a message a few hours before the space station is going to go over your head, and then it says, okay, at 10:58 you're going to see the space station, and then at 10:58 you go outside, and it's going overhead. It's amazing. So I use this as a magic trick for people. I'm like, hey, let's go see the space station. Like, what? And then we walk outside, and there it is.
I use a website called heavensabove.com.
Yeah.
It's heavens-above.com, and you can put in your latitude and longitude or location. And what I like about it is the space station is kind of cool, but what I really like to see is iridium flares, which are these really, really bright flares in the sky. And Heavens Above will predict exactly when and where and how bright the iridium flare is based on your latitude and longitude.
So Peter, what have you got here? This is a this is
M91. So it's a barred spiral. So barred spiral galaxies have that bar across the middle, and then they sort of rotate from the edge of that bar.
So this is also in Coma Berenices, part of the Virgo cluster. It's about 63 million light years away. And the barred spiral is great. I mean, this is probably what the Milky Way looks like. They're not entirely sure what the structure of the Milky Way is, but they think that we have 2 arms in the Milky Way right now. This is sort of the current thinking. So this is actually kind of similar to what the Milky Way might look like. Beautiful image.
Beautiful.
Yeah,
Fantastic.
it's lovely. Yep.
So Emerald One is recommending on YouTube, and I totally agree, which is that if you want to see the night sky and you want to sort of try out different telescopes, make your way to your local astronomy club. And all you need to do is take your city and search in Google for your city or the nearest big city to you and astronomy club, or your province or your state or your province in Australia or your township or whatever, and you'll get a listing of local astronomy club, and then you can find out when their open observing nights are, and then all you got to do is just go down, stand outside, and say, can I look through your telescope? Can I look through your telescope? And they're often just absolutely glad to give you a chance to look through it, and then you can really try them out. You can try out big telescopes and small telescopes, and be looking at different objects, and it's great.
If there's one thing that amateur astronomers like to do is show off their equipment.
Yeah, absolutely. Yeah. So this is great. So now we can actually look right down the barrel of Gary's telescope and see what's inside of it. So
right, the camera's right here, and there's a lens assembly. This comes out. The front part is a corrector plate. It's a lens that adjusts the image, and then it goes down to the back for the mirror and bounces back up. And normally there's a small mirror in here that goes back for visual. Well, this is a lens assembly that goes in place. The camera's here. You can see the fans on it because it's got the cooling. If you cool something, it's going to get hot somewhere else, so they got to get rid of that heat. So that's how it sits there. And then this is on top is my guide scope. I can do generally 2-minute exposures without having to guide. The mount is designed, all good mounts are designed to follow the rotation of the Earth, but it's mechanical and it's never perfect. So if I'm taking a 10-minute or 15-minute exposure, by connecting this up with software, I find a star in this view, and I take a 1 or 2 second exposure each time, and it continually tells the telescope, move a little bit here, move a little bit there. So I can track something across the sky for hours.
Mm-hmm.
Right now, I'm not tracking it all. This is a live view. This is the camera out there.
And so if you're going to do like a really nice deep sky photograph, how long might you be tracking for?
I like 10 minutes for a single exposure, and I like to get 6 to 10 exposures that I can stack up in each color. So, if I do 10, that's about an hour and a half of hydrogen alpha, and then I'll do the same thing in sulfur 2, which is another color red that sulfur gives off, and then I'll do the third one in oxygen, which is a blue-green, oxygen 3. So if it's an hour and a half for that, it's a 6-hour type thing, 4.5 to 5 hours to get a good shot. And then I spend about twice that processing it and stacking them and turning it into a color image. Yeah. Right now we're just taking quick shots in hydrogen alpha, and this is close to what you'd see through a scope looking.
Yeah, some nights we'll actually do some photography, and we'll show you the exact process and show you the final outcome. So can we see what you look like, Gary? Can we actually see the human being behind the telescope? There's Peter.
I like to live my life anonymously, so I don't know.
There we go. Well, that was great. Oh, and now we lost Peter again. So, but I was gonna wrap things up. So thanks, guys. Thanks to everyone who was watching tonight, and thanks to Gary Gonella down in Los Angeles, to Peter Lake down in way down under in Australia, and to Stuart for who's in San Francisco. And thank you. Actually, you're in San Diego right now. Have you been out to that Deep Sky Park that Scott was at?
No, but I do know where he's talking about. I have a good friend of mine who is working on building a remote scope at that exact site.
Oh wow! Okay, yeah. But so thanks guys as always, and we'll see you guys again. We'll see everyone hopefully next week. Now we're going to be recording the next episode of Astronomy Cast tomorrow at 12 p.m. Pacific, 3 Eastern. I don't remember. What's that? 8 in Greenwich Mean Time. So if you want to watch some more astronomy stuff, we'll be doing that tomorrow. I think we're going to be talking about the hazards of spaceflight. So thanks again for joining the virtual star party, and we'll see everyone next week.
Thanks a lot,
Bye.
guys.
Thanks,
Bye.
Fraser. Thank you.
Fraser.